Okay, everybody, we are on the last study of trigonometry. So let's recap what we've done. We started with the study of angles, understanding the different ways we measure angles in trigonometry. We talked about how trig is a relationship between an acute angle and two sides of a right triangle, and that's where the 6 trig definitions come from. So in chapter 1 was a lot of understanding what trig is and all the definitions. So it was a lot of memorizing new vocabulary. The next study was the study of triangles, and we saw the application part of trigonometry, how we apply trigonometry in the real world to find missing sides and missing angles of triangles, and how it relates to navigation. The third part of trigonometry was the study of graphs, understanding that each of the 6 trig functions makes its own unique graph, and how they're similar and how they're different. The last part is the study of trigonometry with identities and equations. This is the pure algebra part of trigonometry, and I'm not going to lie to y'all, this is the hardest part. This is the pure, let's go back to algebra and solve for x. We are going to learn in this next 2 chapters how to solve trig equations and how to work with trig identities. So there's going to be a lot of recalling facts about order of operations in algebra, collecting like terms, factoring, foiling, adding fractions, solving linear equations, solving quadratic equations. So this is truly the meat of trigonometry. Chapter 5 is called identities, and chapter 6 is called equations. So the first thing we need to do is to make sure we understand the difference between what an identity is and what an equation is. Now, they both look alike. For example, in first grade, this is an equation in first grade. This is an identity in first grade. Okay? From Algebra 1, this is an Algebra 1 equation. This is an Algebra 1 identity. Now, what I want you to notice, these are our equations, these are our identities. They both have equal signs. So an equation and identity are both statements that are true. They have equal signs. The difference is, with equations, there only are a specific number of answers that make the equation true, balance. With an identity, you can use any number to make the equation true and balance. So for example, back in Algebra 1, if I wrote 2 plus x equals spot, and I said, what is the solution? What can x be? The only number that goes in this spot that you can add to 2 that will make 5, we all know, is 3. So this equation has one solution, one answer. If I write this equation from algebra, x squared equals 9. I'm asking you, what number can you put in this spot that if you square it makes 9? Well, there are 2 answers that work here. 3 works because 3 squared is 9. Negative 3 works because negative 3 times negative 3 is also 9. So this equation has 2 solutions. And we also recall from algebra, this is a linear equation, has 1 solution. This is a quadratic, has 2 solutions. But that's what you mean by saying an equation. There are a specific number of answers that make it true. That's different from an identity. This is a first grade identity. 2 plus 0 equals 2. Now, if I change this to Algebra 1 and I write it like this, x plus 0 equals x, and I ask you, what number can you put in the spot for x that would make this true? You could put any number in the spot. If you put 3 here, 3 plus 0 would equal the 3. But x doesn't have to be 3. If I put negative 4 in this spot, negative 4 plus 0 would equal the negative 4. If I put a half in this spot, a half plus 0 would equal a half. So the main difference that you need to understand is an identity means an equation. It has an equal sign, but it means no matter what number you put in for the variable, it will always balance. I can pick any number I want to make that statement true. Whereas an equation, you can't pick any number. If you put 4 here, would this balance? No, because 2 plus 4 would not be 5. If I put 1/2 here, would it balance? No, because a half squared is not 9. So that's the difference. Now, there are 11 trig identities that we're going to use in Chapter 5 and Chapter 6, which means you're going to have to memorize. I know I said it the bad word. Memorize. The basic fundamental identities, the ones that we're going to use the most, you have to memorize. You have to know them from the top of your head. So, you're going to say, oh my, that's 11. That's a lot, Miss Black. But it's okay. You already know 8 of them. You just don't realize you know them. So in trig, there are 11 fundamental identities, the basic identities. The first 6 are called the reciprocal identities. Well, we know that word. Reciprocal means to flip. And you already know these. They just haven't been written the way I'm going to show you. So the first one is sine theta. Well, who is the reciprocal of sine theta? It's cosecant. So we would say sine theta is really 1 over cosecant theta. If I take the cosecant value and I flip it, put it underneath 1, I'll know my sine value. Who's the reciprocal of cosine? It's secant. So this is written cosine theta equals 1 over secant theta. Who's the reciprocal of tangent? That's cotangent. So this is written as 1 over cotangent theta. Who's the reciprocal of cosecant? That's sine. So this is 1 over sine theta. Who's the reciprocal of secant? Cosine. 1 over cosine theta. Who's the reciprocal of cotangent? Tangent. 1 over tangent theta. Now, if you look, these are equations. They have equal signs. But they're identities because no matter what angle you pick for theta, this will always balance. So let me prove it to you with the first one. Let's take sine theta equals 1 over cosecant theta. I'm going to prove to you why this is an identity. Pick me an angle for theta. Let's say 30 degrees. So I'm going to write sine of 30 degrees, and according to this, it should equal 1 over the cosecant of 30 degrees. Why did I pick 30 degrees? Because we can look 30 degrees up without a calculator. So let me draw my triangle. There's 30. The side opposite is 1. The hypotenuse is 2. That means the adjacent side is square root 3. Okay, guys, if I want to look up the sine of 30 degrees, I put my finger on 30. Sine is y over r, or sine is opposite over hypotenuse. So it doesn't matter from which chapter we think about it. So if I do y over r, I get a half. If I do opposite over hypotenuse, I get a half. So we all agree the sine of 30 is 1/2. So the left side becomes 1/2. It's got to equal the right side. The right side is 1 over. Now we're going to look up the cosecant of 30. Here's 30. The definition of cosecant is r over y, or the definition of cosecant is hypotenuse over opposite. So that would be 2 over 1, which is 2. Do you see how that balanced? They're both the same value. A half equals a half. Now, what makes this an identity is I didn't have to pick 30 degrees. I could pick any angle I want. What happens if I picked 60 degrees? Okay, just to show you. So I'm going to erase that. And I'm going to do the sine of 60 degrees. And it's got to equal 1 over the cosecant of 60 degrees. So all I'm going to do is take that triangle and draw it with my 60-degree angle. So across from my 60 degree is square root of 3. Hypotenuse is always 2, so that means the adjacent side is 1. Again, I don't care how you think about it. Sine is either y over r, or it's opposite over hypotenuse. Either way you look at it, the sine of 60 is square root of 3 over 2. The definition here, this identity says sine of 60 equals 1 over the cosecant of 60. To look up cosecant, I'm going to say it's r over y, or I'm going to say it is hypotenuse over opposite. Either way, that becomes 2 over square root of 3. Now you're going to tell me, well, those are not equivalent. You're right, because this is not completely simplified. This is 1 divided by 2 over square root of 3. We all know there's no such thing as dividing fractions. You multiply by reciprocal. So this is really 1 times square root of 3 over 2, which gives me square root of 3 over 2. Look at the left side. Look at the right side. They balanced. So that's what I want to make sure you understand before we even get started. The reason why these are being called identities is because you can pick any angle value you want, and this is always going to be balanced. That's why it's an identity. Not one angle works, not two angle, they all work. All right, so you know the the reciprocal identities. You also know the ratio identity. Well, the word ratio implies a fraction. Well, let's think what we know. What do we know about our definition of tangent? It's y over x, correct? And we know from the unit circle the y is the sine value and the x is the cosine value. So your definition that you've already memorized, tangent is y over x. Y is the sine value, x is the cosine value. So now our ratio identity is tangent theta is sine theta over cosine theta. And the same goes through with cotangent. From what we learned previously, cotangent is x over y. Well, x stands for cosine on the unit circle, and y stands for sine. And again, tangent and cotangent are reciprocals of each other. So if you flip sine over cosine, you get cosine over sine. So these first 8, the reciprocal identities and the ratio identities, you already knew. They were just written with terms of x and y and adjacent hypotenuse, all that good stuff. The new ones that you have to memorize are the Pythagorean identities. Now, there's 3 of them. Why do you think they're called Pythagorean? Well, the first thing you think of what Pythagorean is, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. Guys, they have squares in them. Sine squared theta plus cosine squared theta is 1. That is a true statement. I don't care what angle you put here. If you put 45 degrees here and you put 45 degrees here, you find the sine value, you square it, you find the cosine value, you square it, and add them up, it's going to give you 1. If you put 17 degrees here and 17 degrees here, and you look up the sine of 17 degrees in your calculator and square it, and you look up the cosine of 17 degrees and square it, and you add them up, it's going to make 1. You have to memorize that. The second one is 1 plus tangent squared equals secant squared theta. And the last Pythagorean is 1 plus cotangent squared theta equals cosecant squared theta. So first things first, these are all identities, because no matter what angle you pick for theta, it will always balance. Secondly, you knew the reciprocals already. You knew the ratios already. These are the only 3, the Pythagorean, that you have to memorize. Now, in this section, we're going to work with these identities 2 different ways. So let me get your notes, and let's go to example 2. So in your notes in 5.1, let's look at example 2 together. It says, find the remaining trigonometric function values given. Tangent theta is negative 1/4. Cosine theta is greater than 0. All right. What does it mean when it says find the remaining trig function values? How many trig functions are there? That's right, there's 6. They've already given us tangent, so we're missing the other 5. So I'm just going to write myself a note what I'm looking for here. I want to know sine theta, cosine theta. I already know tangent. I'm going to write it down. I know tangent theta is negative 1/4. They want to know cosecant theta, secant theta, and cotangent theta. Now, we've already done this back in chapter 1, but we did this as a graphical approach. We looked at it by drawing the geometry, the triangle, the right triangle. Today's approach is not going to be by drawing a triangle. Today's approach is going to be by using the identities. Show me algebraically how you get the other 5 answers. So, they've given us tangent. Well, if you look at all these identities, they all do not have to do with tangent. So, it doesn't matter which trig function we find first. Remember when we drew the right triangle, we always did them in order, find sine, then cosine? When we're doing this as an algebra approach, it does not matter. My way of looking at it is, I know tangent. Let me find all my identities here that have to do with tangent, and let's start there. So if I know tangent in the reciprocal column, if I know tangent, I can find cotangent, right? Because 1 over tangent would be cotangent. So that's the first one I'm going to find. I know tangent. I'm going to substitute in for tangent what I know, and I'm going to find cotangent. I'm going to do this as an algebra approach, like solving an equation. So I'm going to write my identity, cotangent theta equals 1 over tangent theta. Let me make a stink right now. I know you're online and I'm not collecting your work for all this. But if you're in your notes and you're writing this without the thetas, you're totally wrong. Don't be lazy. Write it correctly. When you write the trig functions, you have to put theta behind them. If you don't write the data, then your work is wrong. Okay, I'm making a note of that. All right, so if you look, I know the tangent theta value. Even though I don't know how many degrees the angle is, I don't know how many degrees angle theta is, I know when I do the tangent of that angle, I get out negative 1/4. So don't you agree we can do a substitution? We can replace tangent theta with negative 1/4. So we would write cotangent theta equals 1 over negative 1/4. Now it just becomes arithmetic, simplified. What is 1 divided by negative 1/4? Well, there is no dividing in fraction land. You're multiplying by the reciprocal. This is really 1 times negative 4 over 1, which is just negative 4. And that's what they want to see. That's how they're getting these values in this chapter, showing your working equations, identities. All right, that was easy. I'm going to erase that. Remember, we're given tangent. Now, what other identities can you use if you just know tangent? Okay, remember, we know tangent, we want to find something else. So we're not going to use this one because we know tangent. We'll have 2 unknowns here. That's not going to help. What about the Pythagorean? If we know tangent and fill it in, we could add it to 1 and find secant. So now we're going to do the Pythagorean because that makes sense. I'm going to write 1 plus tangent squared theta equals secant squared theta. So we're going to do a substitution. 1 plus. We know tangent theta is negative 1/4. We're going to have to square that. That's what it means by tangent squared theta. Take your tangent number and square it. It equals secant squared theta. All right, we're going to do our arithmetic. 1 plus. What's a negative times a negative? A positive. A fourth times a fourth is 1 over 16. How do you add a whole number to a fraction? You need a common denominator. You should all be able in your head to understand 1 is 16 over 16. 16 over 16 plus 1 over 16 is 17 over 16. That equals secant squared theta. Do I want secant squared theta? No. I want secant. So how do you get rid of a square from good old algebra? You do the opposite. You square root both sides. How do you square root a fraction? You do the square root of the numerator. Well, can you square root 17? No. You do the square root of the denominator. Can you square root 16? Yes, it's 4. You should remember from algebra, when you square root, you should have 2 answers. You put a plus or minus. On the right side here, a square and square root are opposites. So what do they do to each other? They cancel out. And that leaves you your secant theta. Now, you can't have 2 answers. Because if you remember, we did this back in chapter 1. We'll do it in a minute like chapter 1. In chapter 1, you drew a right triangle, and when you evaluated the trig function, you got out 1 answer. So how do you decide whether it's plus or minus? No, you don't go eeny, meeny, miny, mo, and just choose. What you do is you read the given information. Not only did they tell you the tangent value is negative 1/4, they also told you cosine theta is greater than 0. So remember, trig functions, depending on what quadrant we're in, depends on if they're positive or negative. First question, if tangent's negative, can we be in quadrant 1? Absolutely not. What quadrants are tangent negative in? Well, if we go back to our buddy, all students take calculus. Tangent is positive in 1 and 3, so it's negative in 2 and 4. That's the first thing. We know if our tangent value is negative, if I draw this triangle, it should be either in quadrant 2 or 4. But if cosine is greater than 0, cosine must be positive. Well, is cosine positive in quadrant 2? No, sine is positive. Is cosine positive in quadrant 4? Yes. So by knowing both of these, I have now narrowed this down that all this information is from quadrant 4, which makes sense. If you're in quadrant 4, tangent's negative, cotangent's negative. But if you're in quadrant 4, what is secant? Well, secant is the reciprocal of cosine. And if cosine's positive in quadrant 4, secant's positive. So when they ask you for the answer for secant, don't give plus or minus. It will be positive square root of 17 over 4. All right, we're halfway done. Okay? So now, if you look, there are no more identities that just have tangent and one other trig function. So now it's your game. Now you know 3 pieces of information, and you're trying to get sine, cosine, and cosecant. Well, remember, they want to see all of these algebraically. So, if we know secant, can't we go get cosine because they're reciprocals? So let's prove it. If I know secant, I can get cosine now, right? So I'm going to do the identity. Cosine theta is 1 over secant theta. I'm going to use my reciprocal. Cosine theta is 1 over secant, which is square root of 17 over 4. But we can't leave that. We have to simplify. There's no such thing as dividing fractions. This is 1 times 4 over the square root of 17, which is 4 square roots of 17, which we have to rationalize. Multiply by square root of 17, multiply by square root of 17, which would give me 4 square roots of 17 over 17. So now I know what cosine is. 4 square roots of 17 over 17. We know we're in quadrant 4. We know cosine's positive. There's all the algebra that proves it. All right, 2 left. We still have to find sine and cosecant. Any suggestions? What would you like to do? There is no right or wrong. You now know 4 trig functions. Okay? Well, let me show you this. If you know cosine and you know tangent, you can find sine, right? So I'm going to use this ratio just to prove to you it works. So the ratio, tangent theta is sine theta over cosine theta. Okay? We know tangent theta. Tangent theta is negative 1/4 equals. We don't know sine, but we know cosine is 4 square roots of 17 over 17. You all agree with that? This says to divide. So to move to division, we would have to do multiplication, right? There's a fraction there. So everybody look. What we're going to do is, if you think about this, just like from chapter 2, if we make this a proportion, we put a fraction bar on a 1, we could cross multiply. Sine theta is going to be negative 1/4 times 4 square roots of 17 over 17. Do you all agree with that? So sine theta equals this 4 and this 4 in the numerator and denominator are going to cancel. That's going to leave you negative square root of 17 over 17. We're in quadrant 4. Should sine be a negative? It sure can. Now, you didn't have to do it that way. Another way to find sine would have been to use the Pythagorean, because you knew cosine, so let's do it that way to show you we should get the same result. Okay? If I would have used the Pythagorean, sine squared theta plus cosine squared theta equals 1. I don't know sine. But I knew cosine, again, was this lovely fraction, 4 square roots of 17 over 17, and I'm going to square it, equals 1. All right? Sine squared theta equals, we're going to square. 4 times 4 is 16. Square root of 17 times square root of 17 is 17. 17 times 17 is 289. Equals 1. So now you have sine squared theta plus this fraction equals 1. So I got to know what 16 times 17 is. Thank goodness we have calculators, so we don't have to do that arithmetic. So 16 times 17 is 272. To move this fraction over here, I'd have to do subtraction. So I would subtract 272 from 289. I need a common denominator, which would be 289. So this is 289 over 289. 289 minus 272 would be 17 over 289. And then to get rid of the square, we would do the square root. So we get sine theta. We're doing the square root of the numerator. You can't square root 17. You leave it inside. The square root of 289 is 17. But a square root is both plus or minus. That's the part you always forget. And because we're doing sine, and it's in quadrant 4, it's negative. So I just wanted to show you, no matter which identity we use, we're going to get the same result. Okay? Now we got to get cosecant. So it's your call. You have 5 out of the 6. How do you get cosecant? Well, there's several ways. You can get cosecant by doing Pythagorean. 1 plus cotangent squared equals cosecant squared, which wouldn't be a lot of work because cotangent is a whole number. So that would work nice. So I'm going to use that. Pythagorean. 1 plus cotangent squared theta equals cosecant squared theta. 1 plus cotangent you found out was -4 squared equals cosecant squared. We're going to do our arithmetic. 1 plus 16 equals cosecant squared. We're going to add 17 equals cosecant squared. We're going to square root. You can't reduce the square root of 17, but technically it's both positive or negative. We're in quadrant 4, so cosecant should be negative. So that's negative square root of 17. That would be one way. Another way to get cosecant would have been to use the reciprocal. Do 1 over sine, and you would have got cosecant. So this is the more algebraic approach to find the missing trig functions. Now, I'm going to just show you from chapter 1. It's the same thing, the same answers we got when we drew triangles. We did this in section 1.3. If you go back to your notes, we did this by drawing the right triangle. We would have said, if cosine is positive, we're either in quadrants 1 and 4. Tangent's negative, so that must be in quadrant 4. So we drew our initial ray on the positive x-axis. We drew our terminal ray in quadrant 4. We dropped our height, our altitude. We made our perpendicular. There's our right triangle. Here's our angle theta. Tangent stands for, in definitions, y over x. So our y value is 1. Our x value is 4. There's a negative here. Well, this is going, x is to the right, so the 4 would stay positive. The 1 is going down, the 1 would be negative. Back in chapter 1, we said, okay, to find the radius, we have to do a squared plus b squared equals c squared. This is not one of our triples, so we would do 4 squared plus -1 squared equals r squared. 4 squared is 16, -1 squared is 1. If I add, I get 17 is r squared. We square root. The radius is the square root of 17, and the radius was always positive. Correct? Then we applied our definitions we memorized. So I'm going to verify that these answers are correct algebraically by checking. So here we go. Sine is y over r. -1 over square root of 17 is negative square root of 17 over 17. Cosine is x over r. 4 over square root of 17 rationalizes to 4 square roots of 17 over 17. Tangent is y over x, negative 1/4. Cosecant is r over y, square root of 17 divided by negative 1, negative square root of 17. Secant is r over x, square root of 17 divided by 4. Cotangent is x over y, 4 divided by negative 1, negative 4. Now, I agree with you. What's quicker? Yeah, draw the right triangle and apply your definitions you've been memorizing now from the beginning. But in this chapter, we're focusing on the algebra aspect. So they're showing you can use these identities to find the trig function values. That's one of their purposes. So really, guys, focus on doing the algebra because you're going to need it as we proceed. All right, catch you in the next video.